So let's say I gave you this problem. I have A C3 dot B4 in hexadecimal, and I want to convert that to octal. Hexadecimal to octal. Octal is base 8, hexadecimal is base 16. Well, you can take this actually, a couple of ways of doing it. This is base 16. We know how to convert from any base to base 10. We did that last time. And we know how to go from base 10 to any base. So I can do it that way. Except it will take me a little bit longer. Because to convert this number to base 10 is going to be what? A is what? 10? I go A for now, I'll change it to a 10, times the weight of that location. 16 to the 0, which is 1, 16 to the 1, which is 16, and the weight of this is what? 16 square, which is 256. Plus C times the weight of this, which is 16 to the 1, that's 16. Plus this times the weight of that, which is 16 to the 0, which is 1. Plus the B times the weight of that, which is 16 to the negative 1, that's 116. Plus 4 times the weight of this, which is 16 to the minus 2, which is 1 over 256. That's in base 10. And if you remember, A means what? Isn't that a 10? 10 times 256. What's 10 times 256? 60. Good. C is what? 12? Remember, A, B, C. A is 10, B is 11, C is 12. 12 times 16. 192. 3 times 1. 3. B is 11, right? 11 over 16. And this is 4 over 256. Which is what? 1 over 64 if you simplify it? Or 4 over 256? Doesn't really matter. So when you add all these numbers, 2560 plus 192 plus 3 plus 11 divided by 16 plus 1 divided by 64, the number is 2755.7033125 base 10. And now I got to try to convert this from base 10 to base 8. A lot of work. So to do that, there we go. We're going to separate the numbers. We'll take the whole number and the decimal portion. Divided by 8. 2755 divided by 8, 344, and a remainder of 3, I think. Is that 3, the remainder? Now we take the 344, we divide it by 8. 43, remainder is 0. We take the 43 divided by 8, which is what?
40 plus 3.
5 plus 3. Yep. 5 plus 3. We take the 5 and divide it by 8. 0 plus 5. Once you hit the 0, that's the end of this one. So when you read that number, it's 5, 3, 0, 3, and there's the point. Now let's look at the decimal portion. We multiply by 2. 0.703125 times, 8, not 2, I'm sorry. We're doing base of 8. Times 8. It's 5 plus 0.625. Take the 0.625, multiply it by 8. What do you know? 5, and what's the remainder? I got a 0. So when you read this, you read them down, that's 0.55. That is a lot of work to do that problem. Maybe there's an easier way to that. Let's see if there's an easier way. So I just used the information I knew from last time. We covered last class, how do you go from any base to base 10, and from base 10 to any base. So maybe I can go directly here. Well, here's what you have to remember. When you have numbers, like let's say 1, 0, 1, 1, 0, 1, what's the weight of this digit? Isn't that 2 to the 1, which is what? 2 to the 0, which is what? 1. The weight of this, 2 to the 1, which is what? 2. The weight of this is 2 to the second, which is what? 4. The weight of this, 2 to the third, 8. The weight of this, 2 to the 4, 16, and so forth, continues. Well, when you list your number, I can do them in octal and I can do them in hexadecimal. Maybe a ruler here will be nice. Where's my ruler? There we go. Oh, what happened here? Hey, yeah. What happened to that ruler there? I need way more than this, but I need 16 rows, 17 actually. I might have one actually, but since I got going on this, let's see, 1, 2, 3, 4, 5, 7, 8, 9, 10, 11, 12, almost there. 13, 14, 15, 16. Whew. Just cut it short. There we go. And I don't really need that wide, but I already started. So decimal on the top. Octal and hexadecimal. When we write the 0, The biggest number in octal is what? 7? I only need 3 digits to represent the 7. The 0 is 0, 0, 0. The biggest number in hexadecimal, that's base 15. Base 16. What's the biggest number? 15, which is the F. So I need 4 digits. 2 to the 14 is what? 2 to the 4 is what? 16. So that's why I use 4 digits for that. This is the 1s, the 2s, the 4. The 1s, the 2s, the 4s, and the 8. So the 1 here, it's 0, 0, 1 in octal. The 1s, again, 1s, 2, and 4. If it's 3 digits, if it's 4 digits, 1, 2, 4, 8. So the 1 is, the 2 is 0, 1, 0. That's what a 2 is. 0, 0, 1, 0. 1, 2, 4, 8. 2 times 1 is 2. 3 is what? 2 and 1? The 1 and 2, that's a 3. This will be 0, 0, 1, 1. It looks like the same, everything, except 1 extra digit here. The 4. The 4 is 1, 0, 0. The 1, 2, and 4. 1, 2, 4. The 5 is 5, 4, and 1. 1, 0, 1. 5 is what? 1, 0, 1. There's a 0 in the front. The 6. Isn't 6, 4, and 2? That's 6. So 1 and 1, you get a 0 here. 1 and 1, you get a 0. The 7, it's 1, 1, 1. The biggest digit in octal is 7. So I'm done with it. That's why I only use 3 digits. 7. What happens if you have an 8? Well, you can't have an 8 in octal. But you can have an 8 here. An 8 is going to be 1, 0, 0, 0. 9. 1, 0, 0, 1. 8 and 1 is 9. There is no 10. We use what? A, we know A is equal to 10. So that's 1, 0, 1, 0. 8 and 2, that's a 10. The B, that's 11. 1, 2, and 1. 1, 2, and 8. 12. That's 8 and 4, that's a 12. 13. 8, 4, and 1. 14. 1, 1, 1, 0, and finally the 15, F, which is 1, 1, 1, 1. Notice that's why I use 4 digits for that, 3 for this. So let me go to that problem I just gave you a few minutes ago. And see if I can do it using this chart quicker. I'll wait till you finish writing. So the problem I gave you a few minutes ago, it was convert A C3 dot B4 from base 16 to base 8. That was the question. What I'm going to do with this to get the answer quickly, instead of spending a page and a half like I did here, I'm going to do it quicker this time. I'm going to use this chart. I'm going to convert that to base 2. Instead of 10, I'm going to go to base 2, because that's really quick for me. The 3, I'm in hexadecimal, base 16. 3 is what? 0011. The C is what? Yep, so I'm writing from right to left. That'll be 0011. And the A will be what? 1010. Oh, that's a B, not an 8. Right? That's a B. B4. The decimal part, the B is what? 1011. And the 4, where's the 4? Right here. 0100. So I went from base 16 to base 2 quickly using that chart. Now let me do the reverse. Let me go from base 2 hopefully I didn't leave any digits out. From base 2 now, I want to change that to base 8. Here's my decimal point. Here's what I'm going to do. Base 8, always groups of 3s. This is one group. This is another group. Another group, another group. Let's look at that number. 101 in base 8. 101. Isn't that 4 and 1, which is a 5? Zero, one, one. 011, isn't that a 3? 000, that's a 0. 011, that's what? 3. Point, let's go to the right. Every 3 groups. 101. 5, 101, 5, and you have 0, 0, 0. You can make it a 0. Do you have to write a 0 at the end? No. Was that the answer, by the way? 5303.55. I can go from 8 to 16, 16 to 8 in less than a minute almost. Convert them to 1s and 0s, then groups them in 3s or 4s. Depends what you have. Yes?
So we get a chart on an exam?
No, you're supposed to know this, the weight. Just remember your weight. Like after a while, you'll know them. If you looked at this one, you go, okay, the 1s, 2s, and 4s, right? So what's 1 and 2? 3.
Yeah,
This one, that's 0. This is 1, 1, 0. 1 and 2, 3. 1, 2, and 4. What's 1 and 4? 5. Let me do another one that way. I'm going to hide the chart too, intentionally for me. And I have 7425.316 base 8. Now I want to change it to base 16. So first I'm going to go from base 8 to base 2. Here's my decimal point. The 5. So that's 1 and 4, that's a 5, right? 1, 0, 1. The 2. 0, 1, 0. 1, 2, 4. The 4. 0, 0, 1 or 1, 0, 0 from the left, yep. And the 7, 1, 1, 1. 1, 4, and 2. 3, 0, 1, 1. 1, 0, 0, 1. And 6 is what? Isn't that 4 and 2, 6? So 1, 1, 0. So I just went from base 8 to base 2. Now let me go from 2 to 16. I'll just write them a little bit with a space. 1, 1, 1, 1, 0, 0, 0, 1, 0, 1, 0, 1, point. 0, 1, 1, 0, 0, 1, 1, 1, 0. And I want to go to base 16. Base 16, that means groups of 4s. Here's the first group of 4, right here. 1, 2, 4. What's 1 and 4? Is it a 5? Next group, 1, 0, 0, 0. That's a 1. And the last one, 4 ones, which is what? 15, which is F. On the right side, groups of 4. 0, 1, 1, 0. That's 1, 2, and 4. What's 2 and 4? 6. The next one, 1, 2, and 4. 7. The last one is 0. You don't need it. You can make it 0, 0, 0, 0. That's a 0. So it's 5, 1, F, 0.67. Yes?
The same rule applies like for the whole numbers if you don't have a full group of 4, like if you had 2 digits on the end, you could just add zeros to the end of it, right?
Correct.
And then
Yep.
that's the same rule.
Yep. If I had a 1 here, I just add 2, it's just like any numbers. Trailing zeros or leading, like if I only have 1 digit here, 1. You go, what is that? You can make it 4 by adding 3 more zeros. Remember, leading and lagging 0 in any base, it doesn't make any difference. So you can add as many zeros you want to make it like a set of 4 or a set of 3 there. And that's the quickest way to convert between binary to octal to hexadecimal and back and forth. You don't have to convert them to base 10, then from base 10 to the other one. Just remember the weight, 1, 2, 4, 8. The weight of each digit, and you should be able to make that chart.